Discover the top challenges faced in blue-green deployment for machine learning models and learn practical solutions to ensure smooth and reliable updates.
Welcome to our channel. Did you know that blue-green deployment can drastically reduce downtime and improve reliability in deploying new machine learning models? Yet, many teams face significant challenges when implementing it. In this video, we'll uncover the top 5 challenges in blue-green deployment for ML and provide you with practical solutions to overcome them. By the end of this video, you'll have actionable insights to ensure smooth and reliable updates to your ML models. Infrastructure complexity is often the first hurdle teams encounter in blue-green deployment. In a traditional deployment model, you might only need a single environment. However, blue-green deployment requires 2 identical environments, one for the current version, blue, and one for the new version, green. This can double the complexity, requiring careful management of resources and configurations. Many teams make the mistake of not clearly defining their infrastructure requirements upfront, leading to bottlenecks and inefficiencies. Simplifying infrastructure can be achieved by using infrastructure as code, IAC, tools like Terraform or AWS CloudFormation, which allow you to manage your environments programmatically. Additionally, containerization technologies such as Docker and orchestration tools like Kubernetes can help streamline the deployment process. By reducing complexity, you can focus more on the performance and reliability of your ML models. Data consistency is crucial in machine learning, where models depend on reliable data inputs. In blue-green deployments, maintaining consistency across the 2 environments can be challenging. Differences in data states can lead to discrepancies in model performance, making it essential to use strategies for data synchronization. Techniques such as database replication and event sourcing can help ensure that both environments have access to the same data. Tools like Apache Kafka or AWS DataSync can facilitate real-time data synchronization. Moreover, implementing data versioning can track changes and ensure that each environment is working with the correct dataset. By managing data consistency effectively, you can ensure that your ML models perform reliably post-deployment.
Despite the best planning, deployments can fail, making rollback strategies essential. Blue-green deployment inherently supports rollback by allowing teams to switch traffic back to the blue environment if issues arise in the green environment. However, without a clear rollback plan, this process can become complicated. The key is to have predefined rollback criteria and automated scripts or tools that execute the rollback quickly and efficiently. Tools like GitOps or Helm in Kubernetes can assist in managing rollbacks by maintaining a history of deployment states. It's also crucial to monitor post-deployment metrics to decide when a rollback is necessary. By preparing for rollbacks, you can minimize downtime and ensure continuous availability of your ML models. Continuous integration and continuous deployment, C/CD, are integral to modern software development, including blue-green deployments. Integrating these pipelines ensures that code changes are automatically tested and deployed without manual intervention, reducing the risk of errors. However, the integration process can be complex, especially when dealing with machine learning models that require extensive testing. It's crucial to select C/CD tools that support your deployment model. Jenkins, GitLab C/CD, and AWS Code Pipeline are popular choices. Automating the testing and deployment phases can help you achieve seamless integration, allowing for faster and more reliable deployments. By leveraging C/CD pipelines, you can improve the efficiency and reliability of your blue-green deployments.
Security is a paramount concern in any deployment, particularly when dealing with sensitive machine learning models. Blue-green deployment presents unique security challenges, as both environments need to be equally secure. This means implementing robust security measures such as encryption, access control, and regular audits. Using security tools like AWS Identity and Access Management, IAM, or HashiCorp Vault can help manage permissions and secure sensitive data. It's also essential to conduct regular security audits to identify potential vulnerabilities. By ensuring that both your blue and green environments adhere to strict security protocols, you can protect your ML models and maintain user trust.
One of the main concerns with blue-green deployment is the cost of maintaining dual environments. Each environment requires its own resources, doubling the operational cost. However, there are strategies to manage these costs effectively. For instance, using cloud services allows you to scale resources on demand, ensuring that you're only paying for what you use. Implementing cost monitoring tools like AWS Cost Explorer or Google Cloud Billing can provide insights into your spending patterns and help identify areas for optimization. Balancing cost and performance is key, as cutting too many corners can impact the reliability and efficiency of your deployments. By finding a balance, you can maintain a cost-effective yet high-performing deployment strategy.
Performance monitoring is a critical component of blue-green deployment, ensuring that your ML models operate smoothly post-deployment. Tools like Prometheus, Grafana, or AWS CloudWatch can help track key performance metrics, alerting you to potential issues before they impact users. Regular monitoring allows you to identify bottlenecks and optimize resources accordingly. For example, if you notice increased latency in the green environment, you might need to scale up your resources or optimize your code. Maintaining high availability ensures that your service remains reliable, even under high demand. By prioritizing performance monitoring and optimization, you can ensure that your deployments meet user expectations and business requirements.
Let's look at a real-world example of a company that successfully implemented blue-green deployment for their ML models. This organization faced several challenges, including infrastructure complexity and data consistency issues. By leveraging tools like Kubernetes for orchestration and AWS Data Sync for data consistency, they were able to streamline their deployment process. The deployment not only improved their model's performance but also increased their operational efficiency and reduced downtime. Key lessons from this case study include the importance of planning, the use of automation, and the value of continuous monitoring. These strategies can be applied to your deployments, ensuring smooth and reliable updates. In conclusion, mastering blue-green deployment for ML involves understanding and overcoming a range of challenges from infrastructure complexity to ensuring security and managing costs. Strategic planning and the use of the right tools are key to successful deployments. We hope this video has provided you with valuable insights and practical solutions. Don't forget to like, comment, and share your thoughts on this topic. Let us know if there are any other topics you'd like us to cover. Be sure to check out our related content for more on ML deployments. Thank you for watching.